Hey, how you doing?
I'm doing good.
Man, you're actually pretty early. I didn't think you were gonna come on. I'm still setting up. It's all good.
My bad.
Let me see. I usually have like two screens, so okay, we're good. All right, so okay, I think I'm good. I'll be back in like 2 minutes.
Okay.
Okay, I'm back. All right. So okay, I guess we can start. So how was your day?
My name is good.
Okay,
How about you?
it was pretty long. I did get your those pictures. Is that like your current homework?
It's like the notes that we're doing in class. That was just an extra packet I had. I have the
Okay.
ones with the notes that I have written on it.
Okay. Is that one due? When is that one? I was wondering, like, I guess today we'll take today. It's kind of like a brief of like, what parts we should work on. I have all I have here are like all the notes that your teacher sent me, and
Yeah.
then some other ones that like I feel like would be good. That especially this thing right here. There's some graphing that you guys are doing now, right?
Yeah.
There's some tricks to the graphing. How do you feel about that, the graphing aspect?
It's okay. The only I'm good with. Okay, I say sin and cause. I know that's not how you actually say it, but that's how it's spelled. So I just say it like that. Okay.
Okay.
I'm good at sin and cause, and I know how the the horizontal and the vertical.
Okay. Okay.
It's just that tangent.
Tangent. You're iffy about tangent. Okay. There's actually the way I would check. Maybe I'll show you. Here, let me just share my other screen. There's this program, you probably have heard of it. Have you heard of like Wolframalpha?
No.
Okay, let me just share this. And this is like a way for you get like maybe it's a you don't actually need to buy anything. Do you see this? Do you see my screen?
Yeah.
Okay, so you don't actually need like what I have here is I use this for tutoring, but I have the pro version because it has like steps. Are you gonna take calculus by chance?
Yeah.
Okay, because like for calculus, you're gonna need like the pro version, because there's parts here where you have to like if you want to check like what you're deriving or some equation, but for trigonometry or like pre-calculus, you could probably just use like the regular version. But here like the way I would use this is so the website is called wolframalpha.com. And if you go to this guy, this is like the first thing you see. And like if you take a look at like like one of the homework problems, right? Like for example, like this is what I usually use to like explain. We'll touch on it like sometime today, but if you know if you're gonna graph something, just like type it here.
Mm-hmm.
And this is just to check. Like you obviously have to like know how to graph each individual transformation.
Yeah.
But the way I usually check is it gives you a graph right here.
Mm-hmm.
And, besides like a calculator, this is like it gives you everything pretty much. Besides that, but in the end, like you want to get familiar with like the shifting and then everything. But at least you have like a quality control or quality checker that will show you, okay, this is what that graph looks like. Even for tan,
Yeah.
right? If you had like tangent right here or anything cosecant, secant, it'll graph it for you right there.
Mm-hmm.
Yeah, we'll touch on that. We'll see. Like, but I was wondering if do you want to start with the arc length first, and maybe let's just talk about it, and then see if you're good at unit circle, and then a bunch of these other ones.
Okay.
Okay. So like, for this one, the arc length, all you have to really do, I think, tell me if your teacher told you how, maybe some of these already, but if you're gonna convert like a radians to like to a degree, all you have to do is times it by this guy. Hold up.
Oh yeah, I was like,
Let me share back my screen. Okay. You see my screen? Do you see my screen? You can see this, right?
yeah.
Okay. So as I was saying, when you're trying to like times or convert radians to like degrees, your professors probably or like teachers probably talk to you guys about doing that, right? And you can also go from like degrees to radians, and it's always good to like do these practices and just like remind, because like I don't know, do you guys have like a final that will encompass like all of the concepts, or is it just test one then everything from test one to test two, or how does it work?
I think the tests are like it's not really including like the other units. So like test 2 would like strictly be about
From test one, right? From test one to test two. Okay.
not no, wouldn't like include anything from test 1.
Okay, but what about like, is there like a cumulative test where you have like the
Yeah,
final
there's
exam?
like a final, but I don't think I have to take it.
You don't have to take it?
Yeah,
Okay.
because you can exempt like up to 3.
Oh, okay, that's good. Okay, well, it's just learning the skill then.
Yeah.
Okay. So for these ones, do you guys? I don't know. Maybe you can tell me. Are you retaking any of these exams or test one?
No, I already retook it.
Okay. So was that good, or did you want to like go over the concepts?
I mean, we can try going over some. The
Okay.
only thing, okay, so I like messed up my notes
It's okay. Okay.
yeah, no. Like I got water in my notebook, so like I lost like some of my notes. But they
Oh
had the
wow.
formula for like area, but I don't remember what it was.
For area of sectors.
Yeah, I'm pretty sure.
It's in here. I guess I can just give this one to you. This is the one that your professor gave me. This is pretty much like the arc length is this guy right here.
Yeah, wait, let me write that down.
And then this is the area. And there's an easy way of remembering these guys.
Mm-hmm.
So like if you take a look at like the arc length right here, you have this as the circumference, right?
Mm-hmm.
And then this guy is just the pi r squared. That's the area, right? So like it's just length over circumference and that's just m over 360, and then the other guy is just area over an actual area of a circle, which is pi r squared.
Mm-hmm.
And then the reason why these are like this, because you are going to be looking at a part of a circle. Like this is part of a circle. So you see this length right here, and then this area of a sector. So that's why you have these qualities, you know, of it's like a length over the circumference, because they're related.
Yeah.
And then you have an area of a sector over what? The area of a circle, right?
Mm-hmm.
So that's how I usually remember it. And then do you get this like formula, like how you apply it here?
Yeah. Could we do it like a question though, so I can like make sure, you know?
Okay. Let's take a look at this guy. Just how would you do this? I mean, I know the answer is here, but like, how would you do that?
Yeah, well, I mean, you would use the length formula, and wouldn't you would put 60 over? Yeah. Okay. Well, it says.
So
Okay, it says, but like you would put like the 60 over 360. Yeah.
And all you have to do here is it gives you this guy, right?
Yeah.
And you're given this guy, right?
Yeah.
So you just plug in the values, and then and one of them is obviously the one that you have to find, which is the length, which is the L.
Yeah.
And then you just rearrange this. How good are you at rearranging the equation? You know how to do that, right?
I mean, I think so.
I'm still trying to gauge, because like, okay, so if that's pretty much like what you have to do with these guys. Like you have this equation, which you have to remember, and then you're given maybe like the length, and you have to find the radius. For the most part, it's just you're given you're given the length of the radius, as well as like the degree and the angle. Let's take a look at maybe like class practice. Let's take a look at this one. Okay, here you go. Try this guy.
Okay, so you would use the m over 360 equals the length over 2 pi r, right?
Yeah, and then this is the arc length formula, and then the area sector. So.
Oh, okay. So wait, okay, never mind.
So this one would be like the radius times the angle.
Uh-huh.
For arc length. So
yeah, so it should be for 20.
So you just have to find you have the radius right here.
Yeah.
And then
okay.
this is in radians. So that's it. You just have to times it. It's really simple.
Yeah, it's just getting like the formulas.
How are you at remembering formulas?
I mean, I can like, if I know them, I can remember them, but I wish that she would give it to us so we didn't have to have them all memorized.
For the most part, like, this is math. Like if it's like a physics class,
yeah,
you are given the formula. But since it's a math class, it's a bunch of memorization. Technically, like I said, you have to find like a relation, like a relationship, and then kind of like understand it that way. Like this guy, it's like length over the 2 pi r, which is just the circumference.
Mm-hmm.
And then for this guy, it's always just the arc length is just the radius times this this thing in between. Just remember the equation and you should be good to go. Okay, so for that one's not that bad. Let's take a look at, what about these ones? These ones are pretty much just applying the equation.
This one, I did not, well, it's not like I didn't understand, but I didn't hear her talk about this at all. Because I was like,
she didn't talk about it? Okay.
So I never really got it.
Was this on the test?
Yeah, it was like one of the questions that I didn't get.
Oh man, okay, let's cover it then. So just like the examples, and so if you take a look at what linear speed is, like that's usually like v, and then angular speed is usually like this Greek letter, like a W Greek letter. So the equation, very important again. You have to remember the equation as they look. And for speed, usually, if you think about it, there's a unit with speed, like miles per hour. That's a unit, right?
Mm-hmm.
So by thinking about speed, you already know what the equation looks like, right? In essence, it's gonna be a length over time, right?
Mm-hmm.
So that's why this is a s over time, which is like the equation, because speed is the units of speed is length over time.
Yeah.
And then for angular speed, it's an angular speed. It's not like a linear, so it's not like distance length. For what you need to do the angle. You have to apply the angle. So the only thing that changes here is this guy, the distance. It's not a distance now. It's a distance around something, which is an angle or rotation.
Okay.
So these two are very much the same. The only difference is the top, right?
Yeah.
Okay. And then like when you're applying this guy, you have to remember again this 360 because it's gonna be for the most part it's gonna be a circle.
Mm-hmm.
And for each revolution, like when you're saying like one revolution of something, it's gonna be like that number of revolution times 2 pi over 360.
Okay.
So maybe it's probably better if we apply it. Let's take a look at
Yeah.
example one. For the most part, like a lot of this is like learning how to apply it. So, for example, this one, what are you given? You're given 140 revolutions per minute. So that's going to be, this is going to be like a angular speed, right? You have to apply this guy. So what is your time here?
A minute.
Okay. And then one revolution, what was that? So this guy is this guy's taking the whole circle, right?
Yeah.
And then one revolution is 2 pi, right?
Oh, okay.
Yeah, 2 pi times. So you have to apply so this 2 pi right here is your theta.
Okay.
And then the next thing is you just pretty much apply it from what you know here. So it's the 2 pi times your 140, and this is 2 pi is rad per revolutions, right?
Mm-hmm.
And 140 is 2 pi rev divided by minutes. And then this angular speed has to be, like I said, it has to be rad per minute. So once you times that, the revolutions cancel, and then you just get 280 pi rad per minute.
Okay. Wait, I'm gonna take a picture of this so I can like look at it later.
Okay.
Okay. Okay.
All right. Let's take a look at this guy. So it says here, find the rotation and revolutions per minute. And given the angular speed, and like again, they're given this W now, this omega. They call this omega. So this omega is 6 pi rad per second. So what you have to do is you need to find the rotation. So if you're given this guy, and you have to divide it by the angle, 2 pi. Usually, this 2 pi, you have to remember this. 2 pi just means the whole circle, that's why. That's 2 pi. One revolution. So 2 pi rad per revolution. And then the units for your like angular speed is always rad per second, right?
Okay.
It's the same thing as this guy. So a linear speed is always a length over time. An angular speed is always rad per second or time, right? Radians meaning like the angle theta. Theta can be radians or a degree, right?
Okay. So wouldn't you have to change it from minute to second if it says in revolutions per minute?
Yep. Yeah. So a lot of these are like you have to do the math first, and then and after that you have to assess, does the units make sense? And after that, that's when you apply the conversion. So after you cancel out units, you're gonna get revolutions per second, and it's gonna be 3. And then how many seconds are in a minute? There's 60, right? So that's it, and that's how you get 180. Which is this.
Okay.
Yeah, that's how you do it. Okay.
Okay.
Okay, was that something new?
Yeah. Okay. Okay, now I get it.
Okay, awesome. Okay. Yeah, let me know what else is there. Okay, so example 3. Let's take a look at this guy.
Okay.
So example 3 is So find the radius now. So, and what are you given here? This is a little bit complicated because you're getting like, he gives you the linear speed and the rate of rotation, which is like your theta. He gives you theta here. So,
Okay.
so when you're given, so you have to find the linear speed first.
Mm-hmm.
From the linear speed, then you get the let me see this one. The theta from the angular speed, and then from that guy, you have to find the radius. And so let's take a look at that. Let's try to do that. So if you find you're given this guy, right? Your linear speed, and linear speed is just s over t, right?
Yeah.
And then so let's take a look at that. It's pretty much just a conversion. So he gives this to you in 20 inches per second.
Mm-hmm.
And then so you convert this to minutes. So 60 seconds to minutes, right? This cancels out, right? And then it's going to be 1200 inches per minute, right?
Mm-hmm.
So, and then you times this by your time. I don't know why they did this in inches right here. That's really... Okay. So I guess they want, is this, oh, I see what they did now. So what she ended up doing here was, so this is V, right? This is your V.
Mm-hmm.
And then like, do you remember this equation, S R theta?
Yeah.
So this S is the same as this S in here, right? This is the same S, right?
Yeah.
So if you plug, and then the ultimate goal is to find this R, right?
Mm-hmm.
So it's just messing around with the equations. You have to get S from here. So it's S, another equation of S, which is like V times time.
Mm-hmm.
And after you get V times time, you plug it in here, but then you still need theta, right? You don't have theta. And where else did you find theta? Theta appears in the angular speed, which is theta over time, right?
Yes.
Okay, and then
There's so much going on.
Okay, let me break that down. What part did you get confused? What part did you get confused?
We're bringing in so many different equations for like one thing.
Yeah, this is the reason why it's hard.
And I just learned the equation, so it's gonna like, okay.
Okay, so let me try to break that down. So it's just, you're given the speed, right? The linear speed is what? What is it? You tell me what it is. What is it?
S over T, right?
Okay, you know that part. How do I get S from this guy? S equals what?
R theta.
V.
Oh. What?
From this guy. VT, right?
Oh. Okay, and then you do the.
And then what else gives you S? There's another equation that gives you S, right?
What is it?
So
Is it the R?
this is one S, but then there's another equation that gives you S, right?
Yeah. Okay.
Yeah. So it's like there's three things happening here, but then you have to put them. You have to use them all together so that you can actually get your final answer.
Okay.
But then it's kind of like scavenging.
Okay, it's literally just rearranged. Okay, I get it.
Yeah, but so you have this S equals VT, but the thing is you're not given you're not given T in this case, right? Let me just talk about the equations first. So you have S over T, S equals VT, and you have we need to get theta. So this other equation, what does omega equal? What does W equal?
Isn't
theta,
it theta over T?
Theta over T. Okay, good. So what is theta?
Like the degrees, isn't it? It's
So
like
theta, no, but how do you get theta from this guy?
I don't remember.
You just times it, right? You times it by T.
Oh.
Omega times T, right?
Yeah, so you switch it. Okay.
So you have this equation for theta, you have an equation for S, right? Both of these guys. So now this is equation 1, this is equation 2. And then your equation 3 is this guy. This is the final thing where everything makes sense, is when you have this guy now, right? The arc length equation. So let's try to rearrange this so you get R, because that's what we're trying to look for. So what is it? Is it S over?
S, yeah, theta.
So that's your equation, right?
Yeah.
Okay, so this is your third equation. So you have this S from the linear speed. You have the theta, or angle of rotation, from the angular speed. And then you put equation 1, right? You put equation 1 in here and equation 2 in here, right?
Okay.
And then you get R, which is what you're trying to find.
Okay.
So that's the equation.
Okay.
That's like the flow of the equations. Like,
okay, fun. Yeah.
you have to do that. Like, you have to be able to, that's like part of the not just now, but like from like maybe in test 2, test 3, it doesn't matter. You have to, like, I would say, this is something you have to hone in essence. The other thing with this as well is you're not given T, right?
Yeah.
So you just assume T as 1.
Okay.
1 minute. That's something you have to like think about. It's like, oh, you're not given T, so what is it? And the reason why you have to do that is so that like you can actually get S and theta, and because in the end they cancel out, I think, right? Doesn't T cancel out?
Yeah.
Does that one make sense? Why it cancels out?
Because there is like, yeah, because it's both.
So like if you have this R equation and then you plug in the V over here, right? Over T, like VT.
Yeah, and then it's divided, so yeah.
And then so this guy cancels out.
Yeah.
So this is another extension if you didn't want to actually like put in the values. So that's actually what you have. And then you're given V, you're also given omega. So that's how I would do that problem. You just plug in the values.
Okay.
That if you get that one, you can do 1 and 2.
Okay.
Because number 3 is like the hardest it can be, I think. Okay, so let's see that. I would just practice like, manipulating these equations, because you could technically, there's many different ways this can be asked. Like if you ever to see it again. So, okay, so this is that. Let's take a look at this next one. How do you feel about unit circles?
Unit circle, I have it all memorized.
Okay, so like if you were given like an angle and then like find the actual, like, well, let me see, where's it say a question here? Yeah, like if you were to do this thing right here, these guys, you could do that.
Then I could do that.
Okay, and then you know the signs, right? Like where they're positive and negative?
Yeah.
Okay, so we don't have to cover that one. Okay. Let's take a look at this guy. This is just a tangent. So that one's kind of similar. What about the reciprocal identities?
That is kind of confusing to me. I know it's just like flipped, but it's hard to have it.
It's just flipped, yeah, in essence. I mean, like, what part of it? Is it like the identity itself or applying it?
It's about like, okay, so I think of like SOHCAHTOA, but it's like,
yeah,
really, like, kind of.
So
well,
what are you?
She doesn't teach it like SOHCAHTOA. She says that like I shouldn't really apply.
No, it does apply. I tell you this because once you learn to apply it, it's one of those things that will like remain. Is like, because like there's so many things in math that you have to like remember, but SOHCAHTOA itself it tells you how to apply it, right? Like the sign of something of this guy is the opposite over hypotenuse, right? And then if you had like what is the opposite of sine? It's the cosecant, right? Cosecant of the angle is gonna be what? It's gonna be hypotenuse over opposite, right? Hypotenuse over opposite. Like if you were to do, let's take a look at this one. Like maybe one of these guys. Find the value of the remaining trig. Okay. Oh, here you go. Here's a good one. So, for example, can you find secant 60 degrees?
Alright, so
This is how I would apply it first. So like, what would be your first step if you were to find secant 60 degrees?
secant is for cosine, right?
Yeah, it's the opposite of cosine.
Yeah, so you would find the cosine of it, and then you just flip it.
Exactly. Oh, what happened?
No.
Yeah, that's what I would do. Is every single time you have the reciprocal, find the opposite, and then like, do the reciprocal.
Yeah, it's just some of them you have to like times it, and then it just goes to the top.
And let me see. And then what about the ones where you have like this negatives? I think I remember. Oh yeah, this guy. Do you know about the Pythagorean Theorem? You know how to apply that?
Yeah, I think so. I watched like a video for this before, like
Yeah,
when I
like this guy. Yeah, like
yeah.
you don't really have to find like the actual cosine of 17 if you have this guy, right? Cosine of 17, and then you know that there's another sine right here, right? You don't have to find what these guys are. You already know because of the identity that it's going to be 1.
Mm-hmm.
Like if they're not the same, you cannot do that, obviously. If they're not the same. And like, let me see. What about these even and odd properties?
Oh, that's kind of weird to me. I don't really.
Okay. So
Okay, so like, is it cosine is even, or is it sine?
yeah, so cosine is
Cosine?
even, sine is odd.
Okay.
The reason why is because of their graph.
Okay.
Yeah, and you just have to remember it that way because of their graph. Like you have this guy, and then you also have like this guy.
Mm-hmm.
Right? Like you have
Oh,
this guy.
okay,
Right?
okay, that makes more sense now because
See?
of the.
Yeah, because of the graph, and I think this is the cosine one. Yeah.
Mhm.
So, anyways, how you would apply that and like the actual evaluation of it, like how I usually get, how they usually present these like problems, is you give you like similarly you have to find and apply the unit circle, but then the sign changes. Like you still apply the unit circle, like of finding evaluating the trig function, but then you know that if there's like a negative value in here, right? The first thing I would do is apply this even odd identity or property. So if you had like sine of negative 30 degrees,
Mhm.
you just apply this guy. So don't evaluate anything yet. Like you always apply that first. So how do you apply it? You take the negative value outside, right? And you make this positive, right?
Mhm.
And if it's like cosine, what is that? Like negative cosine 30 degrees. What is that?
It would still be the same, wouldn't it?
Yeah, because it's even. Because it's even.
Yeah.
And then like, what if you had, and I don't know if you hate like memorizing, but a lot of these track stuff is memorizing. Like the way you have like in arithmetic or geometry or algebra, you can probably get away with like not memorizing a lot of rules, but in trig, calculus itself it's not as much as trig. The reason why trig sucks is all those identities.
Mhm.
But yeah, just remember these identities, and then like when you apply them for like an evaluation of like an angle,
Mhm.
apply them first. Same with these guys. Don't evaluate each one. Apply the identity, see if you can simplify it, and then actually evaluate it.
Mhm. Okay.
Does that one make sense a little bit?
Yeah, that makes sense to me.
Yeah, because the moment that you don't apply it, like for example, you did like sine negative 45, and then you did your unit circle, right? You did your unit circle. You went like this, and then 45 there, and then this is like what 1 or yeah -1. Then this is 1, and this is √2. It's just very confusing. It's better to make that positive and then apply it.
Okay.
Like make this inside positive,
Yeah.
and let the minus sign do its thing by by being applied after you apply the unit circle.
Yeah.
So let's see. Okay, let's try this then. What are these? I guess because there's nothing in here. What is the reciprocal of secant theta?
What do you mean, like if it's even or odd?
No, like what is the reciprocal of this guy? Not even odd. Like what is the identity?
I honestly don't know what you're asking.
Wait, do you see my screen?
Yeah, but like, what do you what do you mean? We were just talking about even or odd. Oh my gosh.
No, this guy right here.
Yeah, for secant.
Yeah, what is it? It's the identity. I'm asking you what the identity is.
Oh, like x over y and stuff.
No, like what is
What
the
does
identity?
it
Like,
mean? I don't necessarily know what you mean whenever you're saying like what is the identity. She just ran.
So secant theta. What is secant theta? That's just an identity, right?
Oh, okay.
Right here.
Okay,
Right
okay.
here.
You're talking about that. I was so.
Right here. Does it make sense?
Yeah. Okay.
Okay. So a lot of times when it's asking for the identity, it's pretty general. You know, you're not being asked what the angle is to evaluate, right? You're not asking. You're not being asked to evaluate. You're being asked what is the identity. That's pretty clear. So what is the secant of theta?
So it's 1 over cosine?
Yeah. And how I remember this is the beginning. You see this guy?
Mm-hmm.
So this is S and this is C, right?
Yeah.
And what about cosine? I'll tell you about cosine afterwards. What is the reciprocal of cosine?
What?
Cosine theta. What is the reciprocal of that?
Isn't it just cosine?
1 over sine.
Oh.
It seems like do you even know what the question is? So like remembering the identity.
No.
When it's asking like an identity, when someone asks you for the identity, it's pretty much just do you remember what the rule is?
Okay.
And that's really what it is for trig. Is there's a bunch of identities that you have to remember. The first one in this case is a reciprocal identity. Then the next thing you have this quotient identity, even odd identity, and then like Pythagorean theorem, and then a bunch of other ones later on. But we're not gonna touch on those yet. Let me just see if the quotient one is in here. So you can look back to it. The quotient one isn't in here. Oh, I think I know what they mean. Okay, what is So okay, let's look back into this. So what is cosecant theta? What is the reciprocal identity of that?
It's 1 over sin, right? Sine, whatever.
Yeah, sine. It's sine. Okay. And
I
then
know, but it's spelled like sin.
I know what you mean. I had that same thing as well. It's but like how like this secant and cosine. This is the trick. Like secant right here. The very first letter is S, right?
Yeah.
And then cosine there's a C as the first letter, right?
Mm-hmm.
So you don't have to remember. You have to like trick yourself or give yourself some tips of like, oh, okay, that for sine there's only this is an S, right?
Yeah.
And then so what about this other guy? So what is the letter in the beginning of cosecant? It's C, right? So secant and cosine, there's always this thing where it's like S and C, and then cosecant and sine is like C and S. Just remember it that way.
Yeah.
So you don't have to like remember so many things. What about this guy? Cosine theta. What is the reciprocal of that?
Where? Cosine theta. It's 1 over secant.
Yep. 1 over secant. They're interchangeable. And then for sine, what about this guy?
Then would it be 1 over cosecant?
Exactly. Okay. That, like I said, it's easier to ask for the cosecant and the secant. It's a little like, oh, what the heck are you asking here for the cosine and the sine,
Yeah,
right?
I'm just confused at what you were asking. I was like, what are we talking about?
But in that sense, you have to clarify. Your professor or whatever, your teacher, like, oh, what the heck does that mean? Okay, what about this guy? Cotangent, what is that?
It's 1 over tangent, right?
Yeah, and then what about tangent? What is that?
Would it be 1 over cotangent?
Yeah, I know it's very elementary. I don't know why you have to even ask these. But like the thing is, knowing the reciprocal and kind of like working through that, and it's like, oh, someone can ask you like these questions and then you can simplify them. The reason why you learn these identities is so you can simplify. Like you're gonna use them to simplify things later on in calculus. You're gonna simplify expressions so that you can take like, other operations. Okay, quotient identities. Tangent theta. I'm just gonna say this out loud. So you know this one, right? Sine theta over cosine.
Mm-hmm.
That's tangent, right?
Mm-hmm.
So what is cotangent then?
Wouldn't it be cosine over sin?
Yeah.
Sine.
Okay. Yeah, C over S. So
Okay.
that's good. And then what? The thing is in here. But anyways, if it wasn't in here, I guess I can just do that. What is cosine of negative theta or
It would
negative
still be
x?
the same, wouldn't it?
So it's just this guy, right?
Yeah.
What about this sine of negative x?
You would like take out the negative.
Okay, so that's good. You have these small rules. Those small rules really apply in Trigonometric identities.
Mm.
You don't really need to know like the concept in essence, and then you're applying it now.
Yeah.
But just make sure that you can tell yourself, in terms of like when you're highly pressured, like, oh, okay, that's what you have to apply. What about this guy? How do you do this guy?
It's the same as sine, right?
You have to do this, right?
Oh, okay.
So what is that? Negative sine. And then this guy is just cosine, right?
Mm-hmm.
And then what? You have to simplify this now. Negative what? Right?
Okay. Yeah.
Did you see how I got that one?
Yeah.
So you have to expand them using the quotient rule, and then like apply the even and odd for each of these guys, and then reapply the quotient rule.
Okay, but why would that make it different than just doing the same as you did for sine if you got the same thing?
You could just remember it, but like usually for sine and cosine, those are the ones that I remember. And for tan, you can just build it off sine and cosine. Yeah, there's merit in actually like, doing whatever I did here.
Uh-huh.
And obviously you could just, take the shortcut and just say like, okay, why don't I just do this, right?
Yeah.
But there are times when you would, like, for example, when you use this later on and you don't remember, you can always go back to this fundamental like fundamental definition of what is a tan, what is a cotangent, something like that. Okay, so I guess I'll just say this, but this Pythagorean theorem, there's the other forms of this guy, right? Like someone could tell you sine squared. If you see sine squared theta somewhere, it could be 1 minus cosine squared theta, right?
Mm-hmm.
And then the reason why I'm saying this is because oftentimes maybe it's not so obvious that you have to apply a Pythagorean theorem. That you like what it is really when you're applying a trig identity, like for that matter, is you have to manipulate your equations so that you can use an identity in order for you to apply it. Just take that now, but then just see it that way. That's like the purpose of the identities, is for you to simplify.
Okay.
And then like they're not always so obvious, like, oh, simplify secant, or tell me what tangent is. It's usually like cosine times tan. What is that? Simplify that one. Sine over cosine. So it's just sine, right?
Mm-hmm.
So cosine times tan is just sine. This is how you usually do it. This is how it's done, like, once it's applied.
Yeah.
Is you have to look for these identities and make them happen if you need to multiply them. Okay. So let's see if we can do these ones. What is sine of 480?
Are we doing
This guy.
Okay. Okay. So we also learned about the one where you minus like 360.
Okay.
Rid of the 2 pi.
Yeah, this is the one. Like when you actually evaluate the this more than 360, you have to minus 360.
Yeah.
And then you have to that's how you simplify it. You'll never really work with a big number. So
Mm-hmm.
so tell me what that answer is first though.
It would be sine 120, right?
Yeah, so 480 minus 360, 120.
Isn't
And it's
that's 3 pi over 2? Square root of 3 pi over 2?
so that value, so that's 120, right? I usually just do it that way. So you have this 120 here, right?
Yeah.
And then so how do you get to 180? That's 60, right?
Mm-hmm.
So you just draw the 30-60 triangle. So what I usually do is you have this 1 here, and then you have this root 3 here, right?
Mm-hmm.
And then you have this 2. Or like, it's the other way actually. Here you go. And then what do you do next?
You would take the square root 3 over 2.
So like you have the 60 degrees here, right?
Yeah.
So the 60 degrees,
So it's like so you're doing like SOHCAHTOA.
so sine of 60 degrees is what?
Sine of 60, that's 1/2.
No,
No, that's
so you're applying
that's square root
SOHCAHTOA.
3 over 2. Okay.
Square root 3 over 2. Yeah, good. So this is how you do it. Like you use a complementary angle. I think that's what it's called, which is like you just minus 360 and then you get 120. But you're not gonna use 120. That's like insane. You have to create some triangles, right? Oh snap! You have to create some triangles that are easy, and usually these triangles are 30-60, right?
Mm-hmm.
Like you have to create 30-60 triangles. What's the other triangle you can create?
90, 45, 45.
Yeah, the 45-degree triangle, which is 1, 1, root 2.
Mm-hmm.
So you have to find ways to make your life easier with these unit circles. Let's try another one actually, because let me see if you can do this one. That one's too easy. Like this guy right here, number 7. Let me just
Would you
erase.
have to do the times thing? Wait.
Yep, you could do that. Make it into a degree. Yeah.
Pain.
I know, right?
Pain. Why do I have to do work right now?
29 pi. Oh wait, 29
pi over 6.
pi over 6. And then was it what pi in the bottom 180, right? Like something like that.
Yeah, 180 over pi.
And this is 1, and what is this on? This is 30, I think. 29 times like 30. So it's 870 degrees.
Mm-hmm. And then you would minus.
How many ever times like 360, that goes into that? Maybe like twice.
Yeah.
So it's 150.
Yeah, 150.
Your angle that you have to work with is 150. So let's work with 150. And remember, we're doing the sine of 150. So where's 150 in the unit circle? What angle do you need to do? 30 degrees, I think.
Mm-hmm. Well, you can still use it because the values are the same. I think our teacher never really did it where you broke it down into square, like into triangles.
Oh, really? It's easy. How did she do it?
Well, for the whole unit circle, it's pretty much the same except like the difference in the quadrants. So it's just like in quadrant 2, it'd just be negative, positive. So the sign.
How do you like it that way though? Like, is it more?
It's all just memorization, I guess.
That's the thing. You just said it, right? It's all a lot of memorization.
Yeah.
Try doing it this way, because the way I'm doing it, you don't have to memorize anything.
Yeah.
The only thing you're memorizing are these triangles.
Mm-hmm.
Because, like, for example, I mean, it makes sense, right? You do this, you turn it into a degree, and then you make sure what the heck you're like looking for. It's a sine. So, what? How can you make a triangle from a 150? You go right here, and then you make a 30-60, right?
Mm-hmm.
And you know what the 30-60 is. You don't have to memorize like what is root 3, root 2. It's really difficult to memorize that.
Yeah.
Especially during a test, like I could do this like way faster than memorizing.
Yeah.
So what do you do? What is sine 150 after you draw this out?
It's 1/2.
It's
Right?
1/2. Yeah.
Yeah.
So easy, like, and then the sign itself. Well, the sign itself is easy, right? There's this thing what they call it like a an acronym for it. It's a SA. Tell me if you've seen this before. SATC. Have you?
No.
Students all take calculus.
Oh, okay.
You never heard of that one?
No.
Okay. That's a lot of times they don't. No one ever actually. I just heard of that yesterday.
Oh, okay. Okay, kind of.
But like, it's easy to remember if you can do stuff like that. Where the significance. What is the significance of this first? Is everything in S right here is positive, like S meaning sine.
Mm-hmm.
So every sine thing here is positive. Every t thing, which is tan here, is positive. Every cosine thing here is positive. And what do you think A stands for?
All of it is positive.
Yeah, sine, cosine, tan, everything, and even the counterparts are all positive. And then, so with whatever I just did here, the 30, 60, and then the 45, 45, 90, and then the signs, you don't have to remember anything. It's just those two things.
Okay.
So like, if you're given any angle, any angle, it doesn't matter what angle you're given, like just do the circle again. What is this? This is 60. So you go down here, right? And this is 60, right?
Mm-hmm.
And then what is opposite of 60? I think this is a 2, 1. And then what is sine at the bottom here is negative, isn't it?
Mm-hmm.
So first of all, what is the sine of 60? The sine of 60 is 2 over root 3. Or I always get this confused. What am I doing? Here you go. It's going to be root 3 over 2. And then this is, since we're doing a sign at the bottom here, it's going to be negative. Since cosine is the only one that's positive.
Okay.
This is the one that works every time for me.
Okay.
Yeah.
Okay, so you can use like basically any angle. Okay.
Any angle, and then you don't have to remember all those like memorization of the unit circle.
Okay, wait. Let me draw this real quick so I can like have it. Okay.
Okay.
So you'd use like the triangles.
Yeah, we can actually do more of it so that you can get acquainted. Let me see. Actually, it's gonna be, hold up. It's gonna be, since the sign of 320 is negative, it's gonna be negative, right?
So positive.
Yeah, so it's gonna be positive. That's gonna be tricky when you apply these things, because it's gonna be negative sine 320. 320 itself is negative because you're in this quadrant, and then you apply the negative. So more practice will really allow you to like parse out those like small things. It's like, oh, okay, that makes sense. Let's try to do more of these. Let me see which one. Try do this guy, cosine of 7 pi over 2.
Okay. Alright, so you would do like times 180 over pi, right? Cancel out.
Yeah, let's try to do that one. 7 pi over 2 times pi times 180. 90, 630, right?
Yeah.
And then what is that? I think it's like 270 minus like 360. Right. So it's going to be the cosine of 270. So no memorization. Where is 270?
270 is going to be like over
this guy, I think.
Over here. Oh wait, you probably can't see me. Yeah, quadrant 4.
Yeah, so like you go here, this is 0 degrees, right?
Yeah.
This is 90 degrees. And this is 180 and then 90 going down. So what is cosine of that guy?
Cosine of 270?
Cosine of, then for me, the way I usually look at this is cosine of like 0 is what? 1, right?
Yeah.
But cosine of 90 degrees, what are they?
Of 90 degrees?
That's
Cosine of 90 degrees? 0, right? Yeah.
yeah. And then this is just negative 90, right? 270
Yeah,
is just
so just go
negative.
down, so it'd still be 0.
So it's 0.
Okay. Yes.
Okay. How do you like these ones?
Those ones are okay.
Okay.
They're pretty.
It-
I pretty much have that one.
Okay. I mean,
I've
what-
just never done the triangles. I just like had it memorized.
if you had it memorized, that's good. Whatever way, whatever fashion you like, you make it work. That's good. At least you have an option now to do this.
Yeah. To do the
The triangle way has always been the way I've been taught. It works every time. Let's take a look at this one. We have like a few minutes. Yeah, let's just take a look at like a bunch of these and try to answer them.
Okay, so that one I'm pretty sure. This one I got wrong on the test because I was not there when she taught this.
The what one? What happened? Which one? All of them?
Yeah, this whole thing where you like plus and minus it.
Oh, okay. Let's try. Do you know specifically which one? Let's try. This one is obviously not. You don't know the prompt for it. Try doing this guy.
Okay. Oh, you crossed it out. Okay.
I'm gonna cross all of them out.
Yeah. So cosine of 30 is square root of 3 over 2, right? Yeah. And then 1/2 for sine.
That's quick. That's pretty good. Yeah, that's the one.
Okay. So how
So you
would
got that one right.
Yeah. How would you add it?
How do you add it? Are you serious? No, I'm just kidding.
Okay.
The-
I think the Zoom
no.
meeting is done.
Okay, so how do you add
Okay.
this?
So okay. Never mind. Okay.
Because it's the same thing, right? The what is it? The denominator.
Yeah, the bottom.
Yeah.
But I mean,
Yeah.
like the top. Like, how do you simplify it?
Yeah, like that's all you have to do.
Which
But
is-
then, did they have this like as an? I don't know how was it a multiple choice one or was it like answer?
No, it was just answer.
If you did this, I think it's fine.
Okay, I did do that.
Yeah, I think you probably got that one right.
Okay, yeah, I did do that. Okay, never mind.
These are
Okay.
equivalent. These are-
No, okay, I was right whenever I did these. Never mind.
Okay. What about this guy? This is just applying. What is it? True or false?
Oh, that it
Yeah. What is this one?
it's odd, so no, right? Wait,
It's this guy, right?
yeah.
For sine, you always take out the negative. For cosine, it's always the same.
Yeah, but they didn't take out the negative.
No, that's why it's false, isn't it?
Okay, yeah, okay. I was making sure. Okay, I was making sure.
Yeah. So this means like it's false, and like whatever they ask you, like they tell you, is this true? Is it true? No, it must be false. Okay.
Yeah.
This one you probably got this one. I know this isn't that bad. Like
No.
converting. Okay. What about this guy? We talked about this one.
It's the same as sine. So you would take it out. So yeah, it'd be negative, and then you would apply it after. So of 60, it's square root of 3, and then so it'd be negative square root of 3.
Yeah. Let's try to see what it is. Okay.
Oh, hey,
Awesome.
let's go.
Good job. There's like, if you could do it that quick, that's good. Like what I would do is another way of doing it, right? Sine 60 over cosine 60, do the unit circle for those and simplify, obviously.
Mm-hmm.
And then what about this? I don't know which ones you got wrong.
I think I got these right actually, but I was
let's try doing this one. This one's a little difficult.
Okay.
So let's see, 410 to 180. What is that? That one's a 0, I think, isn't it? I don't know. Like what sine? Yeah, it is 180.
Wait, what? Does that mean you're timesing it by 4?
Let me see this one. So cosine. Oh no, that's not the one. Sine is 0. Okay, that's okay. So sine of 180, and then plus 2 sine 210. Just do a bunch of unit circles. So So for this one, let me know what you get.
Okay, wait. Can you explain? Wait, so are you timesing it? Can you explain how to do this?
Okay, so the first thing I would do is like split these guys apart.
Okay.
And then like do them one by one, you know? Like, so when you do the sine 180, I would probably do that first. So you
Oh,
have,
okay. So,
right?
okay.
So you go this way and then you go this way. So,
Over.
yeah.
Plus 2.
So I was right. It is 0. What am I thinking? So this whole thing is 0. Because sine of 180 is 0.
Yeah, because it's 0.
And then so you only have 2 sine of 210. And then you want to make this so that you have this really small angle that you can work with. For me, that way works. So what is that angle in this sense? Let's see, 210 minus 180. I think it's 30. So I'm going to do a 30 degrees here. So that's 1, 2, and then root 3. And I'm doing sine, right? So sine would be opposite. So it's 2. What is that? Oh, I see. Yeah, I did get it right. Okay, that's good. I'm just trying to check myself. So sine of 210 is, what is that? Negative 1/2, right?
Of 210?
Yeah, because you're in this
Yeah,
you're in this quadrant.
You're right.
S A T C.
Yeah. Alright. And then okay.
What did you get?
Yeah, it would be -1.
Well, like, tell me how you got that.
Okay, so the sine of 210 would be it would be -1/2, and then you would just times it by 2, which would cancel out the 2 at the bottom.
And in this sine of 210, was this just memorization? You just knew it? Okay.
Yeah.
I really don't agree with that. Like the way I mean, yeah, it's whatever your professor or teacher wants to tell you, you know, or however you guys want it done. It's just like very non-flexible. Cause like,
Yeah.
what if you learn so many other things? You're not gonna. It's like one of those things. The one thing I probably can't remember as much are like the identities, but I definitely know whatever angle I'm given here. I don't have to like memorize.
Yeah.
Yeah. Okay. I think you probably got that one then. That one's not that bad. Convert 100 degrees to radians. Let's see if you can do these ones.
Oh,
try
so you're
try
just
doing that one.
the formula, right?
Yeah. What am I doing? There you go. So 100 over 180. What is that one?
Excuse me?
100 over 180 times pi.
It'd be 10 over 18, wouldn't it? Wait, what?
And then so that's going to be 10, 18. And that's going to be, let's see, that's 5, right?
Yeah, 5 over 9.
And then 9 pi.
And that.
How come they got that number though? Let me see. I mean, it is the same thing. Square root of 3 plus. Oh, I see what it is. Square root of 14. Okay.
Yep.
That's weird. Convert 100 degrees to radians. What did you get for this one?
So then, what would you do if it was 5 pi? If it was 5 over 9 pi, would you have to like split it up?
Is there answer? Did you look at this? This answer doesn't even make sense. What they had was. I'm thinking you divide it by 2, isn't it? No, that's not even correct. Whatever they got.
Okay, sorry, wait. It was muted for a second, so I couldn't hear you. Okay.
What they got isn't correct.
Oh, yeah, because that doesn't make sense.
Look at this.
Yeah,
like, try put this in your calculator and then try doing this guy.
Okay.
Doesn't make sense. Okay, I think there's something wrong with this one. Because that's not the answer.
Yeah.
See, like it's up to you. You can tell your teacher. Definitely, that's like the wrong one. Okay. What about this guy?
Alright. 3/10 of pi over 6, which would be like 3 pi over.
Yeah, if you memorize it, okay. 2 sine pi over 4. Pi over 6. This is just a 30 degree, right? Pi over 6.
Yeah.
And then pi over 4. What is that one? That's just a 45.
45.
Yeah, that's why I remember like the triangles. Now I can make these triangles. Obviously, sine of this guy.
Yeah.
30, 1, 2, root 3. So that's going to be like what? 1/2, 3, 1/2. The bottom one is going to be cosine, so that's root 3 over 2. And then what is this? The 45 degree one. The 45 degree one is going to be 1 root 2. So that's going to be 1 over root 2. Or root 2 over 2. So that's going to be root 2 over 2. Plus root 2 over 2 times 2. Cancel, cancel. Ends up cancel, cancel. So 3, root 3 over 3. Cancel, cancel. Oh, I think I know what they did. This looks familiar.
Okay. Okay.
What in the world?
Wow, nice.
See, you know what I mean? Like that, yeah. Like this can definitely kill someone's like grade if they do this.
Wow.
So, cause like this is a little bit shifted. I don't know about this one. And
so what? How did? Yeah, that equals it, but why was specifically that? That's
11.
not even on the circle.
Yeah, it's not, right?
What? Okay. Nice.
Okay. So anyways, these other ones you can probably do. We'll cover them again. It's not like we have to cover everything today,
Yeah.
Yeah. And what I would like to do though next time is maybe we'll talk about like the graphs.
Mm-hmm.
Just to touch on it. I mean, because I still have you. Like, so you're talking when you're looking at this graph. Like, take a look at what this is. Maybe I'll send this to you. Is like anything like in front of the trig function is the amplitude.
Mm-hmm.
So that what changes when what transforms your how is your graph transform if you have like this amplitude? It's just this guy, right?
Yeah.
And then if you have this like this constant b inside your parentheses, it's gonna be your frequency that's gonna change. Like what that means is, like for example, it goes from your thing goes from 0 to 2 pi if it's just sine, right? Sine over x, sine x. If you have a number in there, like for example, if you had like 2x in there, right? Mm-hmm. Then you just divide everything by 2.
Yeah.
Does this sound familiar?
Yeah.
Okay. And then if you had this h, and this h is a phase shift, so like kind of like a horizontal shift. Mm-hmm. So remember, it's a negative number, right?
So it'd be positive.
Yeah, like if that thing right there is if this guy inside, for example, sine of x minus 2, it's gonna be a right shift. If it's sine x plus 2, it's gonna be a left shift. This is a left shift. This is a right shift.
Yeah.
Okay. And then if you do this thing, the outside one, the k guy, It is a vertical shift, but this is a plus, so it doesn't really matter. So this one is easy to remember. So if you had like sine x plus 2, you're gonna move this up, right?
Yeah.
And sine x minus 2, you're gonna move this down. And then how I usually like graph these guys is I look at sine first, and I go by amplitude, frequency. I do them one by one, is what I'm saying. And then the phase shift, and then the vertical shift. You could attack them all at once, but it gets kind of confusing. We'll talk about it next time.
All right.
Cool. Yeah, let me know if you want me to answer your homework problems. I don't know if is that something you want me to like give you solutions for?
Maybe we could go over it perhaps, but
Okay.
right now I'm fine for this one.
You're good with this one? Okay. When's your next exam?
Next Friday.
Okay. So I don't think let me just ask. Do we need to cover the other things, again, besides like what you guys are doing now already, like the graphing stuff? Like for next time?
Probably not, because it's not really gonna show up again.
Okay. So from now, I guess next time we'll cover like the graphing. And what's after this for you guys,
I'm not sure. She hasn't really told us what's after this.
Okay, we'll just attack the graphing next time. Like all of these guys, I'll ask you to graph them, and then like the harder ones, the tangents and the cosecant ones.
All right.
Cool. For the next one, what did you want to do it? I totally forgot this. Did you want to do it this week, or did you want to do it next week? I think we should do it this week because your test is next week.
Yeah.
When are you free on Saturday by chance? Or when's a good day for you? And let me rephrase that one.
A weekday preferably.
Okay, because my Thursday's really. I don't want to do it tomorrow because it's like the day after. My Thursday. What's like the best day for you for the week besides today?
Excuse me?
What's a good day for you besides today?
I mean, we could do Friday, or we could maybe do Sunday.
Oh, Sunday works for you.
Sunday, yeah, Sunday should work.
Okay, yeah, Sunday sounds good with me. Man, I usually have like 4 clients on Sunday. What time?
Any time.
Let me see. Just to like let's take a look at this. Do you mind if it's like in the evening?
No.
Okay. What if we do like after? What about like 8 my time? What is that for your time?
10.
And like 10 to 11, is that fine?
I'll probably go to sleep by then.
what about 4 to 5 or 5 to 6? My time.
5 to 6 should work.
Okay, and that's like pretty much like right now. So
Yeah.
Okay. Yeah, I'm still trying to grasp like what time. So 5 to 6 are good for you for Tuesdays and Sundays, right?
Yeah.
Okay, I'll just schedule that one for this next one, and then please send me like throughout the week. I know you have like this like more than other people, and some people only have it like because you're in high school, obviously. But yeah, send me all the things that come up. I am coordinating with your teacher. I always say professor. I don't know. with your teacher. So that I will cover, but then it'll be good for me to get feedback from you as well.
All right.
Okay, cool. Yeah, so see you on Sunday, and I will book that. And just text me anything that you have questions on.
Okay.
Cool. Have a good one.
You too.